In this video, I'll be showing you how to calculate compound interest using the future value interest factor, that's the FVIF table, and then explaining the concept of capitalization. Okay, the formula I'm going to be using is future value equals present value multiplied by the factor found in that FVIF table. So here's the word problem. If $8,000 is invested for 1 year in an account paying 12% interest that is compounded quarterly, what is the future value at the end of that year? One key difference between calculating simple interest and compound interest is the consideration of the time period. So think about this. With simple interest, the interest is assumed to be in one whole year increment. So one period would equal 1 year. Problem specifies, however, the interest be compounded quarterly, so you need to divide the year into 4 quarters, right? And quarterly, 1, 2, 3, 4 quarters per year, same amount of time, you're just considering it in a different manner. Now, of course, not only does the number of periods change from 1 year to 4 quarters, but the way you consider the interest changes as well. It's still going to be 12% over the course of the entire year, but it's 4 quarterly instances of 3%, right? So here's why this is significant. Were you to simply use the numbers from the word problem and insert them into the formula, your answer would be wrong because your references on the FVIF table would be incorrect. Okay, here's why. Again, looking at the table 1, future value of interest factor table, you see along the top margin, the interest rate is 12%. You know, this is if you take it straight from the word problem, 12%, and then the first line is one number of periods. That leaves you with a factor of 1.12. Now, if you insert that into your formula, that's going to give you $8,960. You know, the future value of $8,000, 12% interest, $8,960. However, here's what you actually need to do. Instead, you need to divide that 12% interest by 4 quarters. Okay, 12% divided by 4 quarters is 3% per quarter, just like we saw before. And don't forget to multiply the 1 year by the 4 quarters as well. So you've got 1 year, 4 quarters, that's 4 periods. So that is your formula. The FV equals PV times that factor. Now let's go back to the table again, okay? Notice that instead of having the interest rate at 12%, it's at the 3%. And again, the 4 periods along the left-hand margin, that gives you a factor of 1.1255. So if you plug that in our formula, that's going to give you $9,004. Okay? So if you compare the two figures, what we got, using the 12% over 1 year, that gives you the $8,960 versus $9,004. You can see the difference is significant. It's $44. So, and that's just over the course of a single year. So, why is it exactly? I mean, what is it about compounding quarterly that generates a greater amount than simple interest? Well, think about this. Okay, here's quarter 1, that $8,000 in the bank, 3% quarterly interest, that's going to give you $240 for interest. So you get your original $8,000 plus the $240 you just made. That gives you $8,240 at the end of the first quarter. That's called capitalization. Okay, what you're going to do is you take that $8,440 now for the start of the second quarter times 3% quarterly interest. That you see, that's going to give you the $247.20 in interest as opposed to $240, because what you're doing is you're actually dumping the interest from the previous quarter into the pot, and you're going to capitalize that money. So now you don't just apply the interest towards the initial principal. You're going to actually have that interest towards the principal plus the previous interest, right? So let's do the third one. Look at that. Now it's up to $254 in interest. That's why the banks are making a lot of money, right? Maybe we're in the wrong business. Okay. Now, to answer your question, have you wondered why compounding quarterly generates a greater amount than simple interest? Because of capitalization. Okay, since we're on the subject, let me show you the same exact problem and how that works over multiple years. It's not a big deal, okay? Same, what if you got the $8,000 invested for 2 years in an account paying 12% interest per year that's compounded quarterly? What's the future value at the end of that second year? Okay, just like before, you need to divide the interest rate by 4 quarters. 4% or 12% divided by 4 quarters is 3% per quarter. So that's a given. That stays static. It's still 12% per year, and there's still 4 quarters in a year. Okay, so that's not an issue. Here's the thing, though. You have to multiply the number of years by quarters. So you see in that second part, you've got 2 years by 4 quarters is 8 periods. That's where it differs. The percentage per quarter stays the same. The number of periods expands to 8 periods. So now you've got your formula. Future value equals 8,000 times the factor of 3 and 8. Everything from this point on is basically the same as before. If you look up that factor, the FVIF factor on the table, it comes up with 1.2668. Multiply that by 8,000. So that's going to give you $10,134.40 at the end of the second year. So now you know, right?